Hi, I'd like to go over the Unit 2 Fractions as Division unit test that was given last week. I'm going to go over each problem. Please let me know in a reminder through email if you have any questions about how I got an answer or how I graded it or something like that. All right, we're going to start out with question 1. Question 1 states, 5 friends equally share 3 liters of water. How many liters of water does each person get? This question is worth 4 points. As noted up here, work needs to be shown for every problem. Okay, so there's two major things going on in this problem. There are friends and there is water. And whenever we are equally sharing, that's an indication that division is going to be involved. So the question is, do we divide 5 by 3 or do we divide 3 by 5, since those are the two numbers that we're given in this problem? Well, thinking about what's happening here in the problem is going to help us determine which of these two expressions is correct. If I remember that it's the water that's being shared, then I want to choose this expression here because the 3 represents the number of liters of water. So 3 divided by 5 because we have 5 friends. The other option suggests that we're dividing 5 friends into 3 equal groups, which doesn't make sense. So 5 divided by 3 is the expression that's going to help us answer the question, how many liters of water does each person get? Well, students who recognize fractions as simply another way to express a division expression will know that 3 divided by 5 equals 3/5. But if they weren't sure, we can always draw a diagram or a picture. So these 3 rectangles, let's let them represent the 3 liters of water. And because we're dividing the 3 liters of water equally amongst 5 friends, we're going to divide each liter by 5. Now, each friend will receive just 1 piece out of the 5 from each liter. So that means each person would receive 1/5 from each liter of water for a total of 3/5 of a liter of water. So 3/5 is correct. So a correct answer paired with an explanation and work results in a total of 4 points earned. The second question asks us to write a division equation that matches this diagram. So the diagram is labeled here. Well, I should say the length of each of these long tape-like rectangles is 1. So this entire rectangle here represents a length of 1. And this rectangle here is repeated for a total of 3. So we're dividing the whole number 3 by something. Well, if we look at each hole, we see that each hole has been divided into 5 equal sections. So what's happened is we've taken 3 holes and divided the 3 holes by 5. So this is a division expression, 3 divided by 5. Now the reasoning could be as simple as this. I see 3 holes represented by the larger rectangles. Each hole is divided by 5. And that would be enough of an explanation to show the reasoning for why this diagram is represented by the division expression shown here. So we have a similar looking problem. We have a diagram, but we're asked to do a little bit more than we were in the last problem. So after studying this diagram, students are asked to do 4 things. They need to write a scenario or situation that represents the diagram. They need to write a division expression that matches this diagram, as well as a multiplication expression. And then lastly, they need to answer the scenario or situation that they create. So once again, we see that the large rectangles here are labeled as representing 1 hole, and there are 4 of them. And each of those holes are divided into 3 equal sections. So I'm actually going to skip down to B and just write the division expression I see here. 4 divided by 3. Now, another way of thinking about this is I have 1, 2, 3, 4 groups of 1/3. Since the shaded region of each of these holes is equal to 1/3. So 4 groups of 1/3 would be my multiplication expression. Now, since I have 2 expressions that I can work with, I can use these expressions to create a situation or a scenario. So basically, kind of like a word problem. So I could say there are 4 sandwiches shared equally by 3 people. And that's all I have to write. Students could write another sentence and go ahead and ask, what part of a sandwich would each person get? But the question's kind of implied here. So if there are 4 sandwiches shared equally by 3 people, each person would receive 4/3 sandwich. And 4/3 is also equal to 4 divided by 3 and 4 multiplied by 1/3. This is our first area problem, question 4. We need to figure out what the area of this shaded region is here. And to find the area of a rectangle, students needed to remember that area is equal to the length of that rectangle multiplied by the width. So it doesn't matter which side students decide to label length or width. Out of tradition, I usually label the top side here or the bottom side as the length. So we have a length of 4 units, but it doesn't directly tell us or label the width for us. What it tells us is this distance from here to here is 1. But this shaded part here is clearly less than 1. We would have to shade this entire unit here in to show 1 going down the side. So we have something less than 1. But we notice that this whole has been divided into 5 equal sections. And out of those 5 equal sections, 2 have been shaded in. So this indicates the width of this rectangle is 2/5 units, or 2/5 unit, I should say. So to find the area of the shaded region in square units, I simply need to multiply the length, which is 4 units, by the width, which is 2/5 units. And when I multiply this whole number and fraction, I end up with 8/5 units. And remember, these are square units. And explain or show your reasoning, well, we've done that up here. So the work that we've shown, or I've shown in this example, would be sufficient for explaining or showing your reasoning. Question 5. There are 8 ounces of pasta in the package. Jada cooks 2/3 of the pasta. How many ounces of pasta did Jada cook? In math, many times the word of indicates multiplication. And students who recognize that could have multiplied the 8 ounces by 2/3 to find 16/3, which converts to 5 1/3, meaning B is correct. However, let me label here, ounces. I always recommend going back to a picture or a diagram to really understand what's happening. So, while of many times means multiplication, it's important we understand what's happening so we're sure that we need to multiply in a given situation. So if one of these rectangles is representing an ounce of pasta, I'm going to draw 8 of these. So we can pretend that I have 8 ounces of pasta represented here. Now, if I want to find 2/3 of 8 ounces, that means I need to find 2/3 of each ounce and then add them up. Now that means I need to divide each ounce of pasta by 3. And I'm interested or considering 2/3 from each ounce because I'm finding 2/3 of 8. So I'm shading 2 of the 3/3 for each ounce. And now I can simply count up how many thirds I have altogether. So we can count by 2's here, 8 times, 2, 4, 6, 8, 10, 12, 14, 16 thirds. But going back to this idea that of usually indicates multiplication, this is a situation or a diagram of the situation. I have 8 groups here. And there's 2/3 in each group. So this picture shows why multiplying 8 by 2/3 is a reasonable way to figure out what 2/3 of 8 is. Now we're on question 6. A piece of string is 18 inches long, and Jada cuts it into 4 equal parts. What is the length of each part in inches? Select all that apply. So we have some values and expressions here, and we need to select the ones that represent the situation we're given. So here's my string, and let's say, well, it tells us the string is 18 inches, and we want to cut this string into 4 equal pieces. So maybe I make a cut here, here, and here. Well, if I'm cutting things into equal pieces, that indicates to me that I'm dividing. I'm dividing something. In this case, the whole string is 18 inches, and I'm dividing it into 4 equal pieces. So that indicates D, 18 divided by 4, is correct. Now, we can represent all division problems as fractions and vice versa. So 18 divided by 4 as a fraction is 18 fourths, and we see that's an answer choice here in C. Now, the value of 18 divided by 4, or 18 fourths, is equal to 4 and 2 fourths, which is equivalent to 4 and 1/2. Now, because students have not worked with equivalent fractions much this year, this was something they worked on last year and something they'll work on more when we add and subtract fractions, I did not count it against students if they did not select E. So if they only selected C and D, they received full credit for this problem. Okay, question 7 is composed of 4 different parts. Each part is a multiplication problem, and we're either multiplying a whole number by a fraction or multiplying a mixed number by a fraction, or a mixed number by a whole number, I'm sorry. So for A, 1/7 times 28, this means we have 28 groups of 1/7. So if I really had the time and wanted to, I could write 28 1/7, add them all up, and I would end up with 28 sevenths. Or for some students who recognize they could simplify 28 sevenths to the whole number 4, that was also accepted as correct. Now, B and D, we have a whole number multiplied by a mixed number. These were the most oftenly missed questions. Students need to recognize that 15 times 3 and 2/5 would not be 30 and 2/5. They have to multiply this 15 by each part of the mixed number. So 15 needs to be multiplied by the 3, which is where, or I'm sorry, this should have been 45. Sorry. So 15 times 3 and 2/5, students need to multiply the factor 15 by the whole number 3, which is 45, but then also multiply the 15 by the fraction part of the mixed number 2/5, which is equal to 30/5. This alone was acceptable. If students simplified 30/5 as 6 wholes and added it back to 45, they would have received 51, which was also considered correct. C, 2/5 times 6. Again, this means we have 6 groups of 2/5. I could write 6 groups of 2/5 here, but I'm going to multiply the whole number by the numerator. And because we're talking about fifths here, fifths is the denominator. Lastly, we have a mixed number multiplied by a whole number. Again, the whole number part of the mixed number needs to be multiplied by this factor, and the fraction part of the mixed number needs to be multiplied by the factor. So 3 and 4 gives us 12. 9/10 times 4 gives us 36/10. This alone was acceptable. Some students decided to convert 36/10 as 3 and 6/10, and then added that back to 12 to get 15 and 6/10. Again, either way of expressing the product is correct. Question 8. A hiking trail is 7 miles long. Han hikes 1/2 of the trail and then stops for water. Jada hikes 2/3 of the trail and then stops for water. Part A, how many miles did Han hike before stopping for water? We want to explain or show our reasoning to get full credit here. So 4 points were possible for each part here, which is why question A is worth a total of 8 points. So, for Han, he hikes 1/2 of this trail distance of 7. So remembering that 1/2 of, or I'm sorry, of in general, typically means multiply. We can multiply 7 by 1/2, which gives us 7 halves, or 3 1/2. Either product is correct. And because Jada hikes 2/3 of the trail, we can write the expression 7 multiplied by 2/3 to determine how far she hiked, 14/3 or 4 2/3 miles. So it looks like she ran a little bit, or hiked a little bit further than Han. And when we get into adding and subtracting fractions, I'm going to be revealing multiplying and dividing fractions using questions like this. So you notice if I wanted to add part C here to include addition or subtraction of fractions, I could say, okay, well, how much further did Jada run than Han? And that would require students to subtract 3 1/2 miles from 2 2/3 miles, which, because the fractions do not have the same denominator, would require them to first find a common denominator and then write equivalent fractions. But I digress. Question 9. So this was a question that baffled many students, but only once they got to part C. So we'll spend some extra attention on part C here. But first we'll go through A and B. A farm is rectangular in shape. It is 2 kilometers long and 3 kilometers wide. So we're asked to figure out what the area is. So since we have a length and a width, and we know area is equal to length times width, all we do is multiply this 2 and 3, and we get 6 kilometers squared as the area for this farm. Part B asks us, Part B states the farm is divided into 5 equal parts. Corn is grown in one of the parts. Draw a diagram to show where the corn is grown. Okay, well, we know the farm is rectangular in shape. So here's a rectangle. Here's this whole thing's the farm. And we're going to divide it into 5 equal parts. And I'll just color in right here to show where the corn is. So that part of the farm is for corn. So most students made it through A and B perfectly. However, part C represented a major challenge for students. Part C asks, what is the area of the part of the farm where corn is grown? Explain or show your reasoning. Now, this was the most common answer, 1/5. And students who drew a diagram like this saw that 1/5 of the farm is for corn. And that is true. 1/5 of the farm is for corn. But 1/5 is not the area, because what you're saying here, or what is implied here, is that the area that is taken up by the corn is 1/5 kilometers, or kilometers squared. Well, the problem with that is, if each of these sections, each of these 5 sections has an area of 1/5 kilometers squared, that would mean the farm has a total area of 5/5 kilometers, or 1 kilometer. But that's not what we figured out here. We know the area of the farm is 6 kilometers squared. So 1/5 multiplied by 5 doesn't give us 6, it gives us 5. So this is not correct. This baffled students. But we need to remember that the whole farm has that area of 6 kilometers squared. And I want to divide that farm into 5 equal sections so I can figure out what the area of the corn section is. So what did we do here? In concrete terms, what we did is we took something that has a value of 6 and we divided it into 5 equal pieces. So what is the value of one of these pieces then? Well, going back to our understanding that division expressions can be expressed as fractions, this would be equal to 6/5 or 1 1/5. So that tells us the area is actually 1 1/5 kilometers squared. But let's test that. If the area where the corn is grown is the same as the rest of the equal pieces here, that would mean that we could multiply 1 1/5 by 5, and we should end up with an area of 6 kilometers squared. So let's see if that actually is true. Remember, with a mixed number, I need to make sure both the fraction part and the whole number part are each multiplied by the other factor. So we're going to multiply 5 by 1/5, and that's going to give me 5/5. Then I'm going to multiply 5 by 1, which gives me 5. So altogether, 1 1/5 multiplied by 5 is 5 5/5. But we know 5 5/5 is the same as 1 whole. 1 whole plus 5 gives us 6. So 1 1/5 is in fact correct. Now, because this problem, and I will admit this is kind of a higher level type problem, because when students see a rectangle and they're told, well, this rectangle represents a farm, they think of that as one farm. And they're not wrong. It is one farm. But in this case, they were asked to think of one whole farm as having the value of 6 square kilometers. And then dividing 6 square kilometers by 5, or into 5 equal sections, means each of these sections had to equal 6 divided by 5, because that's what the situation represents. This is what the picture shows us. But this was confusing because students would have naturally thought, I need 6 of these rectangles divided into 5 pieces each. So the idea of representing a whole with a number other than 1 is an abstract kind of thing that students are going to be working on this year. So let's look at another problem here. And what I'm going to do is I'm just going to let's just start with pictures. Let's just kind of start from the beginning here. So let's say I have another rectangular area, okay, and let's say this is a parking lot, okay, and we'll say that this parking lot has an area of let's say it has an area of 64 square feet. So it's a very small parking area. And let's say that 1/3 of that parking area is reserved for handicap parking. So to figure out what 1/3 of this area would be, I would have to divide the total area into 3 sections. So what did I do here? Well, I took a rectangle, one rectangle, but it represents 64 square feet and then I divided it into 3 equal sections. Okay? So, knowing what I know about division expressions and fractions, I know that 64 divided by 3 is going to give us 64 thirds. Now, while 64 third square feet is technically the correct answer, that's a really weird way to think about the area of a parking space. So that's where converting fractions into mixed numbers is helpful in some situations. So the most straightforward way is to, again, remember that 64 thirds is the same as 64 divided by 3. And some of our students already know how to long divide or use long division to divide, which is super. If your child is not yet dividing whole numbers yet using long division, have no fear. This is a skill that will be covered this year. So 64 divided by 3 gives us 21. We have a remainder of 1. And since we're dividing 64 into groups of 3, this would be 1/3. And that makes a little more sense. So if we take 64 thirds and turn it into 21 1/3, this value here makes a lot more sense given our context or our problem. So we could say, well, one handicapped parking space has a area of 21 1/3 feet squared. And I'm really just pulling these numbers out of nowhere, so I'm sure this is wildly inaccurate when it comes to actual parking space areas. All right, so again, let's draw one whole rectangle, but instead of assigning it the value of 1, let's assign it the value of 13. And then I'm going to divide that 13 into fourths. And so the situation represented here is 13 divided by 4. And if we go back to the farm example, we could say, a farm has an area of 13 square miles. 1/4 of the farm is set aside for cow pastures. What area of the farm is for cow pastures? Okay. Now this question can be answered by a diagram right here. Okay, so we have a farm. Okay, and it has an area of 13 square miles. We want to figure out what 1/4 of that 13 is, so we divide 13 by 4. We remember that fractions and division are really two different ways to say the same thing. So 13 divided by 4 is 13 fourths. And that's it. That's the answer. Okay, what is the area of the farm reserved for cow pastures? 13 fourths square miles. But again, if we were to convert 13 fourths into a mixed number like this, 3 1/4 square miles, a lot of times that makes more sense or is easier to picture or imagine than an improper fraction like this. So I hope this video helps. Students will be able to make corrections, but again, I need to reiterate that corrections are a privilege. They are by no means a right, and I tell students, pour your heart into them. If all I see is a number as the correct answer and another number as the explanation, or the explanation for their mistake is I got it wrong, that's low effort. And I'm not going to reward low effort. The corrections need to be, ideally from my end, the corrections are a way for students to learn from their mistakes. And then they're rewarded for their efforts by getting half of those points back. So even if students did not receive the grade that they hoped for, there's still plenty of opportunities until the end of the quarter to get that grade up. And I have test correction papers in my homeroom, and they can access those anytime. They can work on those at home. And if you ever have any questions at all, please feel free to contact me through Remind or send me an email. I talked to students today about after-school tutoring. This is something that I've done every year that I've taught. I offer free after-school tutoring, and it's a great opportunity for students to practice skills that they're not quite strong in, to finish work that they need to get done. So I am always available. I tell students I'm available during lunch or recess, depending on which I'm covering. So please know that I'm trying to do everything I can to make your students or help your children be successful in math. So please let me know if you have questions. Thank you for watching. Hope it helps.